This video is for section 3-2, graphs of linear equations in two variables. The solution set of a linear equation in two variables can be graphed on the Cartesian coordinate plane. Here's a picture of the Cartesian plane. There are two intersecting lines called axis lines that meet at this point here called the origin. The horizontal axis is the x-axis and the vertical axis is the y-axis. The coordinate plane is separated into four quadrants. The upper right quadrant is the first quadrant, and then they are numbered counterclockwise, second, third, and fourth. Each axis line functions as a number line. There are marks that are numbered that indicate the distance away from the origin. This is called the Cartesian coordinate plane after a mathematician named René Descartes. So Cartesian from his last name, Descartes. Ordered pairs can be located on the coordinate plane. For example, the ordered pair 1, 3, which has an x-coordinate of 1 and a y-coordinate of 3, is located here in the first quadrant. To locate that dot, you find where x is 1 and draw a vertical line, and find where y is 3 and draw a horizontal line. The intersection of those two lines is the point for the ordered pair 1, 3. As another example, 4, 0 is located here on the x-axis. The x-coordinate is 4, the y-coordinate is 0. So you travel to where x is 4 on the x-axis. One more example. Let's locate -2, -3. The x-coordinate is -2, the y-coordinate is -3. Find -2 on the x-axis and draw a vertical line. Find -3 on the y-axis and draw a horizontal line. The intersection of those lines is the point that corresponds to -2, -3. The graph of every equation equivalent to this form is a straight line. For example, 2x plus 3y equals 6 creates a straight line. Or 1x take away 2y equals 10 creates a straight line. Or 1/4 x plus y equals -12 creates a straight line. Any equation that has this pattern to it makes a straight line. 2 points are needed to locate a line on the coordinate plane, but it's recommended that you plot 3 points for greater accuracy. Points having a 0 as the x-coordinate or as the y-coordinate are convenient to plot. Let's try an example. Graph 3x minus 5y equals 10. This fits the form ax plus by equals c, where the a is 3, the b is -5, and the c is 10. Because it fits that form, we're expecting a straight line. To find the straight line, let's plot 3 points. Remember the suggestion to use 0 for x. 3 times 0 minus 5y equals 10. 3 times 0 is 0. So this is the same as -5y equals 10. Divide by -5, and we get y is -2. 0, -2 is one dot on our line. That's located here on the y-axis. Again, remember the advice. Try 0 for y. 3x minus 5 times 0 equals 10. 5 times 0 is just 0, so this makes 3x equals to 10. Now divide by 3. 10 divided by 3 looks like this, or 3 1/3. 3 1/3, 0 is a point on the line. On the x-axis, let's travel to 3 1/3. Having 2 dots is enough to visualize the line going through at an uphill angle. But let's follow the recommendation of the book and find one more dot. Let's choose another value for x. I'm going to choose 5. 3 times 5 minus 5y equals 10. 3 times 5 is 15. Now we could subtract 15 from both sides. 10 subtract 15 is negative 5. Next, divide by negative 5, and we get y equals 1. 5, 1 is a point on our line. Locate 5 on the x-axis, and then travel up till you reach where y is 1. Do a quick visual check. Does this dot look like it lines up in a straight line with the previous two dots? And it does. Carefully draw in a nice straight line with your pencil. This diagonal line is the graph of our equation. The way that we found that line was plotting 3 points. And the way that we found the points was to choose different numbers for x or y, substitute them into the equation, and figure out the other letter. Let's try another example. Graph the set of ordered pairs x and y such that 3x plus 2y equals 0. And let's only use numbers greater than or equal to 0 for x, and only use numbers greater than negative 6 for y. This description of our set restricts the numbers that we can choose in our table. Can we use 0 for x? Possibly. We just need to make sure that the y value that we get ends up being greater than negative 6. Let's find out what happens when we put in 0 for x. 3 times 0 is 0, so this makes 2y equals 0, and y equals 0. 0 is greater than negative 6. 0, 0 is a dot on our line. Let's choose another number for x, perhaps 2, and see what the corresponding y value is. 3 times 2 plus 2 times y equals 0. 3 times 2 is 6, plus 2y equals 0. Subtract 6 from both sides, and then divide by 2. When x is 2, y is negative 3. Negative 3 is greater than negative 6, so this ordered pair is okay. Here's where x is 2, and down here is where y is negative 3. Let's put a dot there. Let's choose another number for x. How about 4? 3 times 4 plus 2y equals 0. 3 times 4 is 12. Next, subtract 12 from both sides and divide by 2. When x is 4, y is negative 6. But notice that one of our restrictions is the value of y must be greater than negative 6. It can't equal negative 6. So we don't want to have the point 4, negative 6 on our line. Instead, we can put an open dot at that point. Do a quick visual check to make sure the dots appear to line up in a straight line, and then draw in that line. This segment with one closed dot end and one open dot end is the graph of this set. One more example. Graph the set of ordered pairs x, y such that y equals negative 1. If it helps, you can rewrite this as 0x plus y, or 1y, equals negative 1. This makes it look more like the ax plus by equals c format that we know will make a straight line. So we are expecting a straight line. Let's find some ordered pairs. When x is 0, what's y? 0 times 0 plus y equals negative 1. 0 times 0 is 0, so y is negative 1. 0, negative 1 is a point on our line. Let's try x is 1. 0 times 1 plus y equals negative 1. 0 times 1 is 0, so y is negative 1. 1 comma negative 1 is a point on the line. Let's try another number for x. How about 2? 0 times 2 plus y equals negative 1. 0 times 2 is 0, so y is negative 1. Do you see the pattern? No matter what x is, y is negative 1. And isn't that what the original equation says? Y is negative 1. After we've plotted a few points, draw in the line through the points. You'll notice that the equation creates a horizontal line instead of a diagonal line as we had in the last two examples. Let's summarize the lesson. We reviewed how to graph equations with two variables in them, x and y, but we also included an example that only had the letter y. The technique is to plot 3 points, and the way that you plot the points is to choose different numbers for x or y and figure out the corresponding variable.